Welcome to the Actionable ESG Talk series brought to you by AKFI, the Actionable Knowledge Foundational Institute, the world's first nonprofit industry association committed to bridging the gap between ESG, sustainability, and digital transformation. Actionable ESG Talk series bring together great minds to discuss the current state and future state of ESG, sustainability, and digital transformation. I'm delighted to be here with our guest, Dr. Zeinab Ibrahim, recently PhD from the University of Cairo, correct?
Yes, correct.
You are a chemical engineer which previously graduated from the same university in chemical engineering, and you are serving as the energy efficiency section head for Gasco in Egypt, the gas company of Egypt, with over 9 years of experience. You specialize in decarbonization, energy optimization, and sustainable development. All these topics are really dear to our heart in AKFI. Welcome again to our talk show. And Zeinab, the first question maybe we usually ask our esteemed guests, it's the question about the trends and innovation in their area. In particular, what are the trends in sustainable hydrogen?
Hi, Manuel. It's my pleasure to be with you and with AKFI institution. It's really my pleasure. First of all, talking about the sustainable hydrogen trends, it's really a global energy transition, and we are honored to be joined by a global recognized pioneer in green hydrogen. I think let's begin with an overview of where the green hydrogen sector is today. I think, first of all, it will be about three main drivers. The first one for falling renewable energy cost. As we all know that solar and wind prices have dropped dramatically, which makes powering electrolyzers economically viable. Like what? In countries like Chile, UAE, Saudi Arabia, renewable electricity is very cheaper than fossil fuel-based options. That's the first main driver. The second one about the technological improvements. As you know, there is many types of electrolyzers, but the most wide are the alkaline and the PEM electrolyzer, which are more efficient and affordable. The next frontier is the solid oxide electrolyzer, but this type is really in pilot scales and in early editions, and it operates at very high temperature and could reach over 90% efficiency when integrated with industrial heat sources. The third main driver is about the national strategies and subsidies. Over 40 countries now have hydrogen strategies. The EU aims to produce 10 million tons of green hydrogen by 2030. Can you imagine? The US has launched its hydrogen hubs and includes generous tax credit under the Inflation Reduction Act, known as IRA. Another fascinating trend is the sector coupling, using hydrogen to link power, transport, and industry. For instance, surplus solar electricity can be stored as hydrogen, then could be used later for power or fuel actions. That's my opinion. What do you think?
I'll try to unpack it a bit. So the way I'm going to think about it is, what is green hydrogen? So the first part was how green hydrogen is produced. And I understood that it can be produced from electricity through hydrolysis. It can be produced through other high-temperature chemical processes, which not only recovers the sustainable heat produced by other production. For instance, concrete production results is done at high heat, as an example. So this is the sourcing of the green hydrogen. Two main categories. And then there are many applications: direct use as energy for transportation with hydrogen cells, use in industry to produce heat or electricity, to produce back electricity from storage as a storing facility, and Now the question to you, what did I miss? Did I miss any of the processes, the reconverting hydrogen into energy back, like heat or electricity?
Yeah, for instance, startups are innovating fast, especially in the areas like membrane technology, hydrogen drones, AI-based monitoring, and on-site hydrogen generation for EV charging stations. Many larger companies are forming partnership with these startups to accelerate the commercial deployment.
Very interesting. So we are in, let's say, commercial or pre-commercial stage. It's being
Yeah,
already used in the industry. And you mentioned a number of countries where it is used.
yeah, we have many hydrogen strategies all around the world.
Very, very interesting. You are the first actually in our talk series to talk about hydrogen production. So there are a lot of questions that are coming up in the same time in my mind.
Yeah,
Uh,
hurry up, ask me quickly.
I, I will try to. Uh, it's what are the concerns right now? Hydrogen is still and will continue to be a very flammable product in terms of production, storage, and transportation. So what are the current
Look,
concerns?
yeah. First of all, about my research about my PhD studies, and it was a case study for the green hydrogen blending with natural gas. One practical path we have seen is the blending green hydrogen with existing gas. So, hydrogen blending is about mixing a certain percentage of hydrogen into the natural gas. To lower why I have to do this? To lower the overall carbon emissions. And the most common blend being trials is about up to 20% hydrogen and 80% for natural gas known as methane. Okay, so I need to explore more about a pilot project in Germany. They have tested about 15% hydrogen in a gas city grid. What are the conclusions about this pilot project? They have seen about 12% CO2 emissions reduction, no measurable loss in combustion efficiency, and minimal leakage of material degradation. But they have some limitation. For example, the limitations are about the material integrity of pipelines. As you know, hydrogen molecules are very small and can cause embrittlement. Embrittlement is a type of corrosion inside the pipelines. The new pipeline materials and lining help, but we still need ongoing monitoring. So the second one is the combustion characteristic. Hydrogen burns faster and hotter than methane. This change flame properties, which matters in industrial burners and turbines. For the third one, the regulatory standardization is lacking. Each country sets its own limit on hydrogen percentage in gas blends. We need global standards for interoperability. Despite this challenge, blending is a smart solution for an intermediate step. It allows us to start decarbonizing today while we build a full hydrogen economy.
What you're describing is very interesting, and you reminding me of my chemistry lessons. Especially hydrogen is the smallest molecule, right? It has only one proton, one electron,
Yeah, okay.
and as you said, it's very it penetrates very easy through membranes and other materials because of the small molecule. It's
Yeah.
also very flammable once it escapes. It is a high flame or explosive. I don't know. You
Yeah,
have to
its
teach me
safety
about
has
that.
many safety concerns while dealing with hydrogen blends.
So I think this sounds like work in progress, but also very encouraging from what you told us. Is this percentage, like 15% of hydrogen produces 12% less carbon footprint? So that seems
Yes.
to be a very powerful or very effective addition to the natural gas to which is, as you said, industrial produced and so on. Have you seen any experiments to use it directly in transportation, like in fuel cells?
Yeah,
There
yeah,
was the
we can.
discussion years ago about fuel cells for cars, but I don't think it ever materialized to hydrogen fuel cells.
Yeah, we can go deeply for some real world cases that where hydrogen is already making a difference. Let's go break down into by sectors. For example, as you said, for the transport sector, we have it was applied for heavy duty trucks and buses. As you know, hydrogen fuel cells provide longer ranges and faster refueling than batteries. Companies like Toyota, Hyundai, and Nikola are investing heavily. In Europe, over 2,000 hydrogen buses are already in operation. For railways, as you know, Germany now has a full operational hydrogen train lines. This is a game changer for routes that are not electrified. For the aviation, Airbus is developing its net zero e hydrogen plane concept. While commercial flight is still a decade away, small scale hydrogen aircraft already exist. But when we go to the industry sector, for the industry sector, we have many applications like the steel. The steel making is responsible for about 7 to 9% of global emissions. Can you imagine? Projects like Sweden's hybrid use hydrogen instead of coal in the reduction process. The first hydrogen reduced steel was delivered in around the first of 2021 to Volvo. For the fertilizer industry, ammonia used in the fertilizer is produced using hydrogen. Switching from gray to green hydrogen will produce and result in green ammonia production that the world would massively cut emissions. In the refinery industry, refineries are already using hydrogen, mostly green hydrogen, for hydrocracking, for example. Replacing this with green hydrogen is low hanging fruit. Moving on to the power industry, for the gas turbine, for example, Siemens and GE have developed turbines that run on up to 50% hydrogen, moving, and they are looking to moving around 100%. This allows existing plants to be retrofitted for cleaner power generation. And lastly, for residential sector, Hydrogen Village in the UK, Japan, Netherlands, small towns are using hydrogen for heating and cooking. These results are promising, through full-scale adoption will take time. I think they are escalating fast, especially in countries where hydrogen is allied with economic diversification or energy independence goals.
And one thing it's I'll take you a little bit to the electrical part of the
Yeah, of
equation,
course.
if you want, if I may.
No problem.
So the electricity production changed a lot with the introduction, especially of the wind and solar. We are talking now economically about zero cost electricity, or actually negative cost, because it's produced in excess and we need to either store it or just let it disconnect it actually from the grid, because as you've seen in the Spain, it can produce actually the bring the grid down through super production of energy. So the point I'm trying to make is hydrogen seems to also play in the balance, and you mentioned already the gas turbines working 50% and probably working 100% on hydrogen, so they can be a temporary storage of energy until it's needed. In the day you produce hydrogen, in the night you produce electricity from the same system, right? You produce electricity, you store it in hydrogen, you burn the hydrogen later, and you produce electricity again, and you distribute it as clean electricity. Is this a process that you observe in your research?
Actually, I didn't go through it, but I have some knowledge about. As you know, sustainability challenge in hydrogen are many. and they are critical bottlenecks that we must address. We can go through it, as you know. What do you think? We can go through it for the critical bottlenecks for sustainability challenge in hydrogen?
Absolutely. It will be a great interest
Okay.
to our audience.
Yeah. For the production, the first one is the production cost and efficiency. Currently, green hydrogen costs about 2 to 5 times more than green hydrogen. So we need larger electrolyzers for gigafactories and cheaper renewable electricity. So we are on track. Costs have dropped around 60% over the past decade, but it need more to be done. The second one could be the water use. Electrolysis requires purified water. In arid regions like in concerns, desalination is an option, but it adds cost and energy use. We must integrate hydrogen projects with sustainable water management. For the storage, hydrogen is the lightest molecule, so storing it efficiently is tough. Compressed hydrogen requires high pressure tanks. Liquefied hydrogen must be kept at negative 253 degrees Celsius. Emerging alternatives like liquid organic hydrogen carriers, known as LOHC, and ammonia as a carrier, which offer more manageable storage conditions. The fourth one could be the infrastructure. We need hydrogen refueling stations, dedicated pipelines, and export terminals. Without this infrastructure, production and demand are not coming to a scale. This is especially crucial for international hydrogen trade between the global south and high demand regions like Europe. The fifth one could be, in my opinion, the regulations and public perception, safety concerns and regulatory uncertainty slow progress. We need public education, safety demonstrations, and consistent legal frameworks to enable mass adoption. Solving all the fifth challenges will require collaboration across government, industry, and academic wise.
So it's still it seems to develop in multiple directions. We are trying
Yeah.
to find um, safe and fast ways where we can apply it. And there is still research, and there are still a lot of technology hurdles or bottlenecks to be resolved to increase safety, stabilize the hydrogen. It's almost absolute zero when you mention the temperature for storing hydrogen as a liquid, right? Liquid hydrogen. You also mentioned you need uh, purified water, clearly, because otherwise you corrode you have
The
corrosion.
electrolyzer,
But
yes.
but I think electrolysis is used in also in desalinization of the water. So is the process actually resulting in combining back water from hydrogen and oxygen molecules when it desalinizes, and then we can produce also hydrogen and water in the same kind of setting? I don't know if you studied that. It's a question which came back from you mentioned that you need pure water.
Yeah,
So the
but actually, no, I didn't go deeply into this point during my research, so I don't have a specific answer that could be. I have to research and go back to you. Maybe for another
Sure,
time we can go deeply
we'll
into this
we'll,
point.
we'll love to have
Give
you
me
back
some time to
anyway.
research. Yeah, give me some time to research about it, and we go back and another episode or something.
Absolutely. The research question would be, can you use a desalinization process as a dual purpose to produce hydrogen and clean water?
Yeah, it could
Because you
be.
have to
Actually, it could be.
desalinize.
Yeah, yeah, yes,
And it's, as far as I understand, it's an electrolytic process as well.
yes.
So, back to what you said, we are still in a research area, and there are many questions to be answered.
No problem.
Uh, We'd like to have you back, absolutely, and continue the discussion about green hydrogen. I think already we had a theme for our discussions. It's like, can we innovate by reusing or by creating the dual purpose desalinization cells? That may be something of interest for your research, maybe a postdoctorate if you so
Maybe next time.
and before that, we have usually a final question, which is really advice question from your experience. What advice would you like to give to new graduates or professionals, people in the middle of their careers that are pivoting into the sustainability focus, especially in the hydrogen and energy storage that you work so deeply into?
Yeah, thank you. It's a marvelous question for me, and I'm waiting for it for a long time. I know many of our listeners are young professional or student interested in sustainability. It's a great time to enter this field. I think my advice would be for fifth pillars. The first one could be focus on fundamentals. By understanding the energy system as a whole, learn the basics of thermodynamics, energy economics, climate change. These fundamentals are timeless. The second one, you have to be specialized, but stay versatile. Whether it's chemical engineering, data science, public policy, or environmental management, pick a focus but remain open to interdisciplinary collaboration. For instance, hydrogen touch chemistry, logistics, policy, and finance. There are many more to go. The third one, build practical skills. Tools like MATLAB, AutoCAD, GIS, Python, for the or rapid miner for data analysis are in demand, and there is many certifications like life cycle assessment or ESG reporting would also help. For the fourth pillar could be the intern and network. You have to look for internships like green energy firms, think tanks, or governmental agencies. Join networks like Yongo, Hydrogen Europe, or Women in Green Hydrogen to build connections. My last advice could be stay informed, stay critical, follow trends, but don't get lost in hype. Read reports from IEA, IRENA, McKinsey, and the Hydrogen Council. Understand where the science ends and where speculation begins. Lastly, have courage. The green transition needs bold thinkers, not just followers. If you have any idea, pursue them, and innovation starts with one person daring to ask why not. Thank you.
Thank you. Thank you, Zainab. And
Thank
actually,
you.
we came up with a question during our discussion today, right? Can we use hydrolysis with double purpose, for instance? And as you mentioned, uh, it's science, it's innovation, and this power of will. It's the desire of people to move
Yes.
forward. You also mentioned something very interesting. There is a organization that I didn't know about it. It's Women in Hydrogen. So
Yeah.
I hope our audience will search for it while they're watching our interview. Definitely, I
I
would like to
follow
have you
them
back.
on LinkedIn. I don't have any relations with anybody there, but I'm following them on LinkedIn. It's really helpful, and they are working on many targets for the sustainability and especially for women.
Oh, excellent. So keep in mind for the audience that you can find on the LinkedIn and probably multiple groups interested in hydrogen in different parts as we discussed today. I would like to thank you for taking the time today to visit with us. For our audience, make sure to tune in every week for a new episode of AKFI Actionable ESG Talk series. You'll gain new perspectives on how to mitigate risks and create value by integrating ESG and digital transformation. Until next week, goodbye from Manuel. Thank
Thank
you,
you,
Zeinab.
Manuel. Thank you so much. See you. Bye.